Algebra 2, Concept 34, Angles and Radian Measure. So in this unit of trigonometry, we're going to expand your understanding of angles. And now, rather than just two rays floating and coming together, we're going to think in trigonometry of angles as a rotated ray. And angle measures that can be any real number. So that means positive and negative, which is different from angles in degree measure that you've looked at before. So we're going to first of all talk about a concept called angles in standard position. So in a coordinate plane, an XY axis, and if you look over on the right of the screen, you can see that an angle can be formed by fixing one ray called the initial side and rotating that ray, and then where it ends is called the terminal side. So we're going to rotate that initial side, and where it ends is the terminal side. So that ray was imprinted in standard position on the positive x-axis with the vertex at 0, 0 at the origin, and then it rotates and stops and imprints itself for the terminal side. So an angle in standard position is when its vertex is at the origin and its initial side lies on the positive x-axis, as you can see. So the measure of an angle is positive when the rotation of its terminal side is counterclockwise. And you can see that I have that blue arrow drawn from the initial side up to the terminal side to indicate that that angle is rotating counterclockwise. Now we could think of an angle rotating the other way. So that angle could actually be rotating that way, and that would be a negative rotation. And we would give that as a negative angle measure in degree right now. And another interesting fact, take this away, is that the terminal side of an angle can rotate more than 360 degrees. So as you see, I have shown a rotation of that initial side all the way around past where it was at the beginning and then further. So we can have angle measures that are greater than 360 degrees. So let's practice drawing some angles in standard position. The first thing you want to do is create an XY axis, and then we're going to label what we call the four quadrants with 0 degrees, 90 degrees, 180 degree, 270, and 360. All right, let me stop this a little bit. That was going a little faster than I wanted. Okay, now we're going to create and draw the initial side, so that has its vertex at 0, 0 and is on the positive x-axis. And then I know that an angle that is 240 degrees will be in quadrant 1, 2, 3. Because it is between 180 and 270 degrees. So I'm going to draw that terminal side. And I'm just going to guesstimate. I don't have to be exact. And now I am going to show the rotation direction with that little rotational arrow, that it is rotating counterclockwise, and it definitely is showing an angle of positive 240 degrees. All right, let's try the next one. So 500 degrees. First we're going to draw that XY axis and then label your angles, 180, 270, and 360. All right, now the initial side is going to be along that positive x-axis with the vertex at 0, 0. And then the initial side, so 500 is past 360 and then past 90 and a little bit more. So it's going to end up in quadrant 2. But I need to show that it's rotating around, that it's doing a complete revolution and more for 500 degrees. So I show that little rotational spiral, and I am going counterclockwise because it is a positive angle. All right, now negative 50 degrees. So again, we're going to do the same thing. Create our XY axis and label those quadrants with the angle degree. And then the positive side, and I know that if it's rotating 50 degrees, it will not be quite at the one quadrant, and it's rotating negative, so we're going to be down in quadrant 4. And then just to demonstrate that, or to show that it's a negative angle, it's rotating clockwise, so I'm going to draw that arrow there, and then it definitely, that is showing a negative 50 degree angle in standard position. So again, just a different way to think of angles, angles that are of rotation. Trigonometry is used in the application of anything that rotates. So I have a brother who's a mechanical engineer, and he says the math that he uses the most is trigonometry. There are lots of rotating parts with engines, and he works for a company that builds engines. And so trig is used a lot. All right, now we're going to talk about coterminal angles. So this term, if you look at it, break it down, co means with, and terminal or term means end. So a coterminal angle is an angle that begins and ends in the same position as a given angle. Coterminal angles are one or more rotations apart. So they can be found by adding or subtracting the degree equivalent of a rotation. So adding or subtracting multiples of 360 degrees. So either you add 360 degrees, so that it would be one rotation further in the positive direction, or subtract one rotation further in the negative direction. An example is 500 degrees is a coterminal angle with 140 degrees. You just subtract 360. So we're going to find one positive and one negative angle that are coterminal with negative 45 degrees. So the first thing we can do is, it doesn't matter if you add or subtract. So let's add 360 degrees. So an angle that's positive, rotating positively, that begins and ends in the same place as negative 45 is positive 315 degrees. And now let's subtract 360 degrees. Oh, sorry, that should be 360. And so that would be 405, negative 405 degrees. For 395, we're going to subtract 360. And notice we're still at a positive angle. So to get to a negative coterminal angle, we're going to need to continue to subtract. So negative 325 degrees will begin and end in the same place as positive 395 degrees. All right, let's subtract 360 and get negative 280 degrees, which is coterminal with 80, and then let's add 360, and we get 440 degrees, and that is also coterminal with 80 degrees. 230 degrees. So let's subtract 360, and that'll put us into the negative. So we found a negative coterminal angle. So let's start back at 230, and let's add 360 degrees. So what we're doing is we're just finding the angle that is one more rotation around, that begins and ends in the same spot. With 740, we're going to need to subtract, and that'll take us down to 380 degrees. So notice, to get negative, we're going to have to subtract 360 two more times. So we get negative 340 degrees. Now I'm only showing you two possible answers, but if you've been thinking about it, there are an infinite number of coterminal angles, because we can continue to add or subtract 360 degrees. And angle measures now, as I said in the first slide, can be any real number. So we could go infinitely positive, many rotations, or infinitely negative. Negative 135. Let's subtract 360 degrees, and that puts us at negative 495 degrees. And then for a positive coterminal, let's add 360 degrees. So if we were to draw any of those pairs of coterminal angles in standard position on an XY axis, they would begin and end in the same spot. Now, one note is that I have starred B and E. And here's a note that you probably want to add to your notes. I'm going to scoot through this one because I rewrote this a little more neatly. All right, so here we go. I wasn't happy with that. So here's my note. Sometimes you need to add or subtract 360 degrees multiple times to arrive at both a positive and negative coterminal angle. And so you'll just have to judge that. And that's what I did on B. I noticed I needed to subtract 360 degrees twice. That gave me my positive and then my negative coterminal angle. And then E, I needed to subtract 360 degrees 3 times to get into the negatives. All right, now in the next video, we are going to do an activity, and you can do this activity with me. You can watch me do it. If we were in class taking notes, we would all do this together. So I want you to discover another type of way that we can measure angles. This is called radian. And as you imagine, the word radian is very close to the word radius. And so it does have something to do with the radius of a circle. And now that you have learned that in trig we can think of angles as rotated rays, so if I rotate this, and then if I were to draw that path of rotation, you can see that if we continued with that, we would have a circle formation. Now, the nice thing about radian measure is that it is in terms of the radius of this type of angle, which is if we rotated all the way around and traced its end point here, we'd have a circle. It's related to the radius, and so that is just a length. And so radian is not a different type of unit than a number. So degree is definitely a different type of unit, but radian is just a real number. And so what's nice when we use radian angle measures in math problems is that we do not have to convert one unit to the other because it's all in terms of real numbers. I know that's kind of a mind boggler, but that is one beauty of radian measure. Okay, so now we're going to end this video, and I need you to go to the next video, number 2, and it's the Discovering Radian activity, and then you will go to the third video to finish the notes on this section.